So before we get into our next topic for this unit, I want to talk about multiplying fractions one more time. A little review is going to be really helpful for when we get into proportions next. So just a quick reminder that when we multiply fractions, remember that we are just simply multiplying our numerators. So I have 2 times 3, and we're multiplying our denominators, right? 15 times 4. So I'm going to go ahead and multiply those. I have 2 times 3 is 6, and 15 times 4. So I'm going to do this mentally. I'm going to say, okay, well, I know that double 15 is 30, so I'm going to double that again to get 60 because I'm multiplying by 4. So I have 6 over 60. Question is, can I simplify that? Yeah, I can, because I know that the numerator and denominator both have a factor of 2, so I could do that. They're both even numbers. But I can go further than that, and I can say, well, they both have a factor of 3. Yeah, but let's keep going. They both have a factor of 6. So in other words, if I divide 6 by 6, I'm going to get 1, right? And 60 divided by 6, I'm going to get 10. So my final answer is going to be 1/10. So that's normally the way I would multiply fractions, right? That's the way we're used to doing it. Now, one more quick review. Remember that if we have mixed numbers, we have to first turn those into improper fractions, right? So if I have 1 1/3, remember this 1 right here just stands for 3/3. So really I have 3/3 and another 1/3, which is going to give me 4/3. And the way we like to think of it a lot of times is using that process, that procedure. 1 times 3 plus 1 is going to give me my numerator. I like to think of it as 3/3 plus another 1/3 is 4/3. So now I have 4/3. Same thing here. So now I have 2 whole things. So 2 whole things would be 16/8, and I have another 5/8, right? So 16/8 and 5/8 is going to give me 21/8. Now again, I could just say 2 times 8 is 16, so I get my 16/8, plus another 5 is 21. So 21/8. Again, I'm going to multiply this, right? So 4 times 21 is going to give me 84. All right? And 3 times 8 is going to give me 24. Now again, I'm going to have to go through this long process of turning this back into a mixed number, simplifying everything because we have a common factor, and go through all of that. Now, so if I do go ahead and finish this, I know that's going to be a mixed number. Well, I want to simplify it first. Let's say I don't know what the greatest common factor is. I want to say, well, they're both even numbers, so I can split them in half, and I have 42 over 12. Right? And if I keep going, split them in half again, I'm going to have 21 over 6. No more common factors, so now I'm going to go to my mixed number. So again, this is just a review. How many 6s are in 21? Well, there are 3, right? So 3 6s is 18, so I have another 3 left over. So I have 3 and 3/6. Well, it looks like we didn't simplify all the way. So I need to keep going. Now I have 3 1/2, right? 3/6 is the same as a half. It just seems like kind of a long process for a relatively simple problem. So I'm going to show you a shortcut. But this is going to be a shortcut that makes a lot of sense. So pay attention. Follow along and write this in your notes. So my first example right here is 2/3 times 15/8. Now normally we would just say, okay, 2 times 15 and 3 times 8, right? Well, what do you remember about the commutative property of multiplication? Commutative says that we can switch the numbers around in a multiplication problem, right? We can switch our factors around to give us a new expression. So 2 times 15 really is just the same as 15 I try to color code this. Times 2. I can do that, right? 2 times 15. 15 times 2. Same thing. I'm just going to go ahead and leave my denominator as is. So I have 3 times 8. Now, what does that do for me? Well, if I take a look at this now, what it looks like to me is that I just have 2 new fractions. So now I have 15 thirds and 2 eighths. Well, I can simplify 15 thirds, right? If I take 15 over 3, I'm just going to get 5 over 1. 15 over 3 is the same as 5 over 1 because I have a common factor of 3. And I can do the same thing with 2 eighths. If I simplify 2 eighths, whoops. We're going to try that again. So 15 over 3, again, same as 5 over 1. Or 15 divided by 3 is just 5. Now 2 eighths. If I simplify that, take a second. What am I going to get? So simplify 2 eighths, 2 over 8. And I'm going to get, hopefully you had in your notebook, 1/4. See what happens when I go ahead and multiply these. 5 times 1 is 5. 1 times 4 is 4. I don't really have to simplify this any more than just turning it into a mixed number. So now 5/4 is just 1 1/4. I don't have any factors to think about anymore. I don't have any large numbers to work with. I just simply have to turn it into a mixed number. So when I do this, or what some people call cross-canceling, and we call it cross-canceling just because I'm simplifying 2 eighths and I'm simplifying 15 thirds. So that's why we call it cross-canceling. It makes the process a little bit easier. So let's try that with the next one. So again, if I flip these around, let's just take our numerator and flip it around. I'm going to have 18 times 5 instead of 5 times 18. Again, I can do that because multiplication is commutative. I can move things around in multiplication. And in my denominator, I'm just going to leave that the same. So I'm going to have 9 times 25. Again, you can kind of see that I'm crossing here. So what can we simplify? Well, if I have 18 over 9, I'll highlight that for you. So if I have 18 over 9, I can simplify that to just 2 over 1. Now I have 2 over 1, and I can simplify 5 over 25 into 1/5. Everything looks much simpler, no big numbers to work with. Now what do I have? 2 times 1, and I have 1 times 5. And no simplifying to do at the end. So let's just try one more. So again, if I switch things around like I did in the last 2 problems, I can see that I'm going to simplify my fractions. But this time, oh, and by the way, this one, remember I have mixed numbers here. So the first thing I did here is turn those into improper fractions. Make sure that you take your mixed numbers and turn those into improper fractions first. So that's what I did in this step. And again, over here I could switch things around, or I could just look diagonally. Okay, so now I have 15/4. So can I simplify 15 over 4? 15 and 4 do not have a common factor, so I'm not going to simplify those. But then let's look at my next one. So now I have 21 over 7. Can I simplify 21 over 7? Well, sure I can. 21 over 7 is the same as 3. In other words, 7 is a common factor, so 21 divided by 7 is 3. And using 7 as my common factor again, 7 divided by 7 is 1. So a lot of times you're going to see it written in this way, where they don't actually switch the numbers around, but just look diagonally. I would encourage you to do it this way, actually swapping your numbers around using that commutative property just to get used to it. Once you're used to it, once you're used to it, you can just do it this way, and you can look diagonally and do it a little bit more quickly. But let's finish this problem off. So 15 times 3 is 45. 1 times 4 is 4. Again, no common factors. So I'm done simplifying that way, but I do need to turn this back into a mixed number. So how many 4s in 45? Going to be 11. And that would be 44 fourths, which means there's 1 fourth left over. And again, no big simplifying to do, no large numbers to work with. Makes multiplying fractions, and as we get into proportions, it'll make that a little bit easier as well.